Hello and welcome to Physics 101. Today we're going to be learning about voltmeters, ammeters, and multimeters. First we're going to start with the voltmeter. The voltmeter does exactly what you would think it does. It measures voltage, otherwise known as electric potential, over some space. Now, the way that you need to think of a voltmeter is when you put something in parallel with a section of a circuit, the two sections of the circuit now that you've created are, are equipotential. And basically what that means is that the potential over the two bits of the circuit are the same. Now because this voltage is the same over both branches of the parallel circuit, we can use, or the parallel portion of the circuit, we can use it to measure the voltage drop over this resistor. But the only way that that can happen is if the resistance of the voltmeter is essentially infinite, right? It has to be so large that what it does is it blocks any current, any reasonable amount of current, any non-negligible amount of current from going through the parallel part with the voltmeter and making it so that it doesn't affect the functionality of the circuit. So for all intents and purposes, the circuit is the same. The only difference is that this is here to measure the voltage. So let's say that the current running through this resistor was known to be 3 amps. Then an easy way to determine what the reading would be on this voltmeter, and in this case what the chemical potential would be of this cell, would be to use the equation V equals IR, or voltage equals current times resistance. So in this case, voltage would equal 4 ohms times 3 amps. That means that the voltage is 12 volts. It's pretty simple. Voltmeters are relatively straightforward, and that's pretty much it for voltmeters. An ammeter is a device that's designed to measure current. Now this works a little bit differently from a voltmeter in that the ammeter has to be in series with the entire circuit to measure the circuit, or to measure the current running through that part of the circuit. It's not, if it's in parallel and it has infinite resistance like the voltmeter, then it would tell you that the current is 0 because none of the current would be flowing through that ammeter. So instead, it's in series, and the effective resistance of the ammeter is as close to 0 as the manufacturers can possibly make it. So for our intents and purposes, we're going to call it 0 ohms of resistance. Now where it is in the circuit, in this circuit, no matter where it was, it would still have the same reading, because all of the current, it's not in a parallel branch, so all of the current of the circuit has to run through it eventually. So if we wanted to find out what the reading on this ammeter would be, it'd be the same process. We would use V equals IR again. Again, voltage equals current times resistance. In this case, the voltage is 9 volts from our 9-volt battery. The current is unknown, and the resistance is 4 ohms. So, if we quickly solve for I, we will find that 9/4 amps is the current. That's a terrible 9, 1 second. 9/4 amps is the current. Again, pretty straightforward. The key things to remember, an ammeter essentially has no resistance, and it has to be in series with the circuit as opposed to in parallel like with the voltmeter. Now a quick note on multimeters. Multimeters are essentially voltmeters and ammeters combined into one. When they're acting as a voltmeter, like when you want to measure electric potential, it would still be hooked up in parallel just like a voltmeter would be, and in that case the internal circuit that's running through the multimeter would be aligned in such a way that the resistance would essentially be infinite, just like in a voltmeter. And same thing with an ammeter, it has to be in series, and when it's arranged in that way and it's configured to measure for the current as opposed to for the voltage, then the effective resistance of the multimeter is in that case basically 0. So same exact thing, it serves the same purpose. So yeah, that's it. Uh, Thanks for watching.